Hi everyone. The question here is to find the domain and the vertical asymptotes of the function y equals 1 over 1 minus ln x. Let's start with the domain. This means that we have to find the values of x for which this function exists. First, we know that ln x is defined when x is strictly positive. Second, we know that 1 minus ln x should not be equal to 0 because it is a denominator. Solving separately the equation 1 minus ln x equals 0 gives ln x equals 1, and by applying the natural exponential function to both sides, it gives us x equals e. Hence, our function is defined when x is strictly positive and x is not equal to e. In other words, the domain of the given function is the open interval 0e union the open interval e infinity. Let's check now the vertical asymptotes, starting with the suspicious points, which are here the endpoints of intervals in the domain, which means x equals 0 and x equals e are suspicious points for vertical asymptotes. Once the suspicious points identified, we now compute the limits. Let's start with the limit when x approaches 0 plus of 1 over 1 minus ln x. Note that the function is not defined on 0 minus. Now when x approaches 0 plus, we know that ln x approaches negative infinity, which means that 1 minus ln x will approach infinity, and 1 over 1 minus ln x will approach 0. This means that we do not have a vertical asymptote at 0, since the limit when x approaches 0 plus is not infinity or negative infinity. Let's now check the limit at e, starting with x approaches e minus, for example. Now when x approaches e from the left, ln x will approach 1 from the left because ln is an increasing function. So 1 minus ln x will be something like 1 minus 1 minus, which is a 0 plus, and the function will approach 1 over 0 plus, which is infinity. Since at least one of the one-sided limits at e is infinity or negative infinity, we can state that x equals e is a vertical asymptote, and actually it's the unique vertical asymptote of this function.